Okay, now that you have your image here, make sure that you click save because I did not save earlier, and when I signed out and then I signed back in, my image wasn't there. Now, if you don't see it when you sign back in, click on the little menu bar and you should be able to see the saved graphs, current graph and saved graph. So click on the saved graph, it should show your image there, and if it doesn't, that means that you didn't save it before you signed out. So you open your graph and it should still be there. Another thing to just keep track of, when you resized your image, so when you first uploaded it and then dragged the box, you change the width and the height automatically changed. Now mine happens to be close to square. So just keep track of this number so that in case that you lose your image for whatever reason, you can upload it again. And let me show you how we would do that. We would close it. So I deleted it, okay? And let me click save. And you see now, if I go to my save graphs, it's not there anymore. I lost it. Well, I can go to the plus, add image. It should still be in my documents folder because I haven't deleted it, and it's right there, Angular full body render. And it uploads it again, but it's small. So I would have to resize it, but I remember what the width was. It was 40. And so I'm gonna change this to 40. Oh, it didn't lock the aspect ratio. Let me undo that. Okay, let me leave it at 10. Let me see, there should be an option here. Well, let me just drag. I'm gonna drag it here to 40, right? Let me put here 40. Oh, it doesn't change. It should change the height, and it didn't. So I'll just leave it like that. I resized it. I'm not gonna put 40 here because when I put this at 40, it doesn't automatically change the height. And what that does is that it might make it too skinny. For example, like I put 20, you see, it distorts the image, and we don't want that. So let me undo that, or let me just close it and then upload it again, image. I'm in the documents folder, Angular full body open, and I'm just gonna drag once again until I get close to 40. And that's probably as good as I'm gonna get. Okay, and then make sure you save. If you don't save, you will lose your image. Okay, so let's start graphing here. First thing I want to do here is I'm gonna work on the straight lines. Wherever I see a straight line, so there's probably like some right here, maybe the close, but definitely the tie. So I'm going to draw the tie first, and let me show you how we do that. We're going to go back to our understanding of lines. Let's draw in here, and I just want to give you an example of how we make lines. So this is review, but if you don't remember, that's fine. It's been a while. Okay. All right, so I have a graph here, and I'm gonna place 2 points. So let me draw. I'm gonna pick the purple. Okay. Let's place a point right here. This is 3, 4, or 4, 3, right there. This is 4 to the right, 4 up. And then let me place another point right here. This is 1 to the left, -1, up 2. And if we don't recall, let me explain how we get the equation of a line. When you have 2 points, which is what you have here, you can label them x1, y1, and x2, y2. So x1, y1, x2, y2. It doesn't matter which one's which. Now the first thing we're going to do, well, we want to get the equation of the line. And the equation of the line is y equals mx plus b. Recall that m is the slope. So that's the slope. B is the y-intercept, like that. So the first thing we want to do is get the slope, and to get the slope, we use the slope formula. That's y2 minus y1 over x2 minus x1. y2 is 4 minus y1, that's 2 over x2 is 4 minus x1 is -1. Remember, I'm going to put that in parentheses. I subtract. Recall that when we're subtracting a negative number, we add the difference. And so this is 4 minus 2 is 2. And 4 plus 1 is 5. 2 over 5. So m is 2 over 5. Now that we have m, we can substitute that into our equation. So y equals 2 over 5. That's what m is. X plus b. Now we want b. We want to know what b is. And so for that, we're going to pick one of the 2 points. It doesn't matter which one you pick. It really doesn't make a difference. Always try to pick the one that you think is going to give you less trouble. And so in my case right here, I'm going to pick this one because they're both positive. I'm going to place y2 where the y is at. So that would be 4 equals. And then x2 where the x is at. So that would be 2 over 5 times, instead of x, I'm going to put a 4 plus b. And notice that the unknown, what we're solving for, is b. Okay, so now that we have this, let me see if I can get rid of that. There we go. And now that we have this, we can multiply. Oh, great. Got rid of the little color selector. We're going to multiply 2 over 5 times 4. And when we multiply fractions, we multiply the numerator. Well, we place a 1 under the whole number. So that would be 4 over 1. So we multiply 2 times 4, then 5 times 1. That's 8 over 5. And then if you want to use a calculator, I have nothing against that. But we start thinking about 8 divided by 5. As a matter of fact, I encourage you to use a calculator. You might be drawing quite a few lines and you don't want to be doing this division by hand all the time. So 5 goes into 8 once. That's 8 minus 5 is 3. And if I put a 0 and bring that down, 5 goes into 36 times. And I place the point right there, right? And we have now a remainder of 0. And so that's 1.6. And finally, I subtract the 1.6 from this side right here. And so I'm going to minus 1.6, minus 1.6. And that is 2.4 is equal to b. And now that we know b, now we have an equation for a line. The final equation is y equals 2 over 5. You can leave it as a fraction, that's fine. Or if you want, you can change it to a decimal. Again, you can divide, okay? Dividing is easy. Use a calculator if you need to. Plus 2.4. I'll divide just so you can see what the slope would be. 5 goes into 2 0 times. Place a point. 5 goes into 24 times. And so it's 0.4x. It doesn't make a difference how you do it. But now you have an equation, right? Like that. This is how we get the equation of lines. Now, part of your task in this project is going to be to carry out this process for the straight lines. And yes, it can be a little bit of time. It can be a little time consuming. But you have time. So now let's go to our drawing or our Desmos drawing and see how this works. How we're going to be doing this in Desmos. Let me connect my laptop, my screen back. We'll come back to this in a minute because I'll probably have to, let me add a page here. I'll be using this in a minute. So if I go to view and I want to put some lines there. Okay. Now let me go here. The first thing I want to do is place 2 points. And the placing of the points for, I guess, let me save here just to make sure that I have no issues with my drawing. Okay, the first thing I want to do, I'm going to zoom in. You can zoom in with the scroll. And then if you click home, it zooms in too much. So let me zoom out. I'm pretty sure we can make this our home now. Let me see here. I'm going to put, I want the Y to go no more than 20 down. And the X to go no more than 20 upwards. So 20, 20. And I want the same for the, that's for the Y, I'm sorry. I want the same for the X axis, 20, 20. Is there a way to make this my home? I think that's good for now. Okay, so we're at 20 by 20. Now let's place a point right here where the, I want to draw this line right here. So I'm gonna eyeball the points here. It looks to me like right now we're at going by ones. So it looks to me like this point is 1 unit, maybe 1.5 to the left. So that would be negative 1.5. Negative 1.5, comma. And it looks like it's almost 6 units down. So I'm going to put negative 6. You see the point right there? It's pretty close. I'm going to zoom in a minute and I'll change it if I have to. But there's 1 point. It's purple. Let me see if I can add a label and you can see it. Maybe I'll put P there for point. So it's right there. I'm going to add another point that is over here that looks to me like it's negative 3 to the left, and there's negative 10, like negative 11.5 maybe. So I'm going to put here negative 3, negative 11.5. And then I'm going to add a label. And it's right there. It's a little hard to see. I'm going to zoom in right now. Okay, here's the 1 point. And then this one seems like it went a little too far down. So let me put not 11.5, 11.3, moves it a little up. Okay, that's much better. Okay, these look good. They both look good. If I remove that, you can see the points here. I'll call it N. So those are the 2 points. Let me put the image back, and they're like right where the tie has to be. Good. I'm gonna save at this point to make sure I don't lose any of my work. Now I'm gonna do what I just showed you, but now using these points. So I'm gonna formulate the equation of that line using this process right here. Again, yes, it takes a little bit of time, but the whole point here is, all right guys, I'll call it line 1. The whole point is for us to do a little bit of math. Let me just take a quick look at my points once again. Negative 1.5, negative 6, negative 3, negative 11.3. Okay. That's because I need to detach this so I can draw a right easier. Okay, so the 2 points were negative 1.5, negative 6, and negative 3, negative 11.3. And so this is the process that you're going to do for these lines. You're going to do the same process multiple times. First thing we want to do is identify x1, y1, x2, y2. We want to get the slope using the slope formula. You subtract the 2 y's and then divide that by the difference of the x's. So negative 11.3 minus a negative 6 over negative 3 minus negative 1.5. Remember, when you're subtracting negative numbers, you change the subtraction to a plus, and then change the sign on the next number, plus, plus. And so negative 11.3 plus 6. Oh. That's negative 5.3. So negative 11.3, that's 4, and then 5, yes. And then negative 3 plus 1.5 is negative 1.5. Notice they're both negative, and when you divide a negative by a negative, you get a positive answer. If you want, by all means, use a calculator. 5.3 divide by 1.5. Oh. Notice that there's quite a few numbers. Just keep 2 numbers after the decimal. That's enough. So I'm going to keep 2 numbers after the decimal. That would be 3.53. Okay, now that I have the slope, now I need to get the y-intercept. And so remember that we have y equals the slope, 3.53, x plus b. Again, I'll write the equation here because I didn't write it, but mx plus b, right? Now I want b. You can pick either of the 2 points. It doesn't matter which one you pick. So I can pick this one or this one. I always like to pick either the positive ones or the smaller number ones. In this case, the ones with the smaller numbers are this one. So I'm going to put negative 1.5 where I see an x. I'm going to put negative 6 where I see a y. So negative 6, that goes there, equals 3.53 times x. Instead of x, I'm going to put negative 1.5. And then plus b. Again, use the calculator. There's no need to multiply this by hand. 3.53 times 1.5. You take your calculator out. 3.53 times 1.5 equals 5.29. That's negative 5.29. And so I'm going to add 5.29 plus 5.29. Those cancel. And right here, that's negative 6 plus 5.29. Again, by all means, use the calculator. That is negative 6 plus 5.29 equals negative 0.71. And so I have negative 0.71 equals b. And my final equation is going to be y equals m, the slope, that's 3.53, x minus 0.71. And that's what I'm going to plug in to Desmos. And hope that it goes through the 2 points. So I have this equation. I'm going to click here on Desmos. Excuse the laptop here while it's loading up. Okay, I'm going to zoom out. There we go. I'm going to come in here and I'm going to say, I don't have to put the y equals, but it's probably best that we do. We put 3.53 x minus 0.71. And just confirm that that's the equation, 3.53x minus 0.71. Yeah, that looks right. And I go to Desmos right here. And what I want to do is I'm going to temporarily hide my image. And notice how the line goes through the 2 points, which is what I want because I want to make the tie. I want to make that tie right there. It looks to me like it could be a better fit, but it's okay. You know, for now, we can play with this later on. This looks good to me. So we have that tie. You're going to be doing the same here. So I see I need another line here. I need another line here, another one here. I could probably get away with doing a line here as well for the top, and then maybe a horizontal line. And we're going to be doing the same for the other ones. But we're right here, so I want to talk a little bit about domain. domain. Okay, domain. This is something that you're going to see a lot more of when you move on to Algebra 2. And that's why you're doing this, you're working on this final project, because it's supposed to prepare you here for Algebra 2. Now, if you go to this, I'm gonna get a few things here. Okay, the points. I'm gonna sketch them, okay? And I'm gonna do my best. I'm gonna try my best to get a straight line. There we go, something like that. And so we have this point here. Let me change the color here for a minute. Okay, we have x1, y1, and x2, y2. It just so happens that the way it's been drawn, this is point 1, and this is point 2. Point 1, point 2. Right? The equation of my line is y equals 3.53 x minus 0.71. Now, let's talk a little bit about domain. Domain is how you restrict your line. So we restrict line horizontally. What that means is, let's say that you want to graph your line, but you don't want the line to go on forever to the right, and you don't want it to go on forever to the left. And so what we're going to do here is we're going to say, I want this line, but I don't want it, I want it to stop, basically. That's what we're going to say. I want it to stop right here, like if I drew a line right there, and I want it to stop right here. So I don't want it to go further to the left, and I don't want it to go further to the right. And so the domain restricts, it's going to restrict the line horizontally. What we're going to do here is we're going to look at the x coordinate. In this case, it's negative 1.5. Actually, I'm not interested in the y coordinate, so let me not write it down. Negative 1.5 is the x coordinate of 0.1, and negative 3 is the x coordinate of 0.2. And so when we say that we want the line, we do want the line, but we want it to start at negative 3, and we want that to be the negative less than x, less than negative 1.5. And I'm going to put this like this in curly braces, like that. And so what this means, this is what we call the domain. That means that we want x, we want the line, we want to graph the line, but only for x values that are more than negative 3 and less than negative 1.5. And so think of these as your bounds, meaning that's where we stop. We don't want to go more than negative 1.5. We don't want to be less than negative 3. Notice the less than and greater than symbols right there. I am taking the x coordinates here. That's where I'm getting those numbers from. That's a negative 3, negative 1.5. I'm not caring too much about the y coordinates. And so we're going to restrict the domain of the line. And so let me show you how that looks on our graph. We're almost done here. So if I go to my graph right here, this takes a minute to load up just here. If I go to my graph, and let me save first just to make sure that everything's good. And then if I click this off, notice how the line goes on forever. After I graph my line, I put these curly braces like that, and I put the domain that I just talked about, negative 3, less than x less than negative, less than negative 1.5. Notice how my line now it doesn't go on forever. It stops at negative 3 to the left, so it never goes past negative 3. Right here you see that's negative 3. My line never goes to the left. And then negative 1.5 is right here. My line never goes to the right. And adding the domain here, that stops your line so that it doesn't go on forever, which is something that we want. We don't want the line to go on forever because the tie doesn't go on forever. If I click there, notice there's the line. Now that I have this, by the way, one last thing here that I want to mention: you put the less than symbol and then you put equals. It adds the equals there, less than or equal to, and then here less than or equal to, which is fine. You can do that as well. It just makes your line go to that point. If I delete it, it's not like visibly you can't see a whole lot, but to ensure that it actually gets to negative 3, you put the equals, which I'm okay with. You can put equals there. And again, if I just zoom out a little bit here to my like 20 by 20 grid, there we go. And then I place the image, there it is. Now there's a few things here that I recommend while you're working this out, because you're going to be working this out. Save constantly so you don't lose your work. Also, I'm going to encourage you to start labeling every point. So add points. You can erase them later on. You can actually erase them, but I don't want to erase them just yet because I'll probably use them again. So you can hide them so that they don't show up, but label your points. I would start by labeling them like 0.1 like that. P1, and then the next one P2. And leave the labels. At the end, you'll be able to delete all this. Just get rid of it. But don't delete it yet, because this point, for example, P2, I'm probably going to use again. I can actually see how I'm going to use it, because I want to use it to make this line. Let me show you. Right here, I would make 0.3 right here at the end where the tie is at. 0.3 looks to me like it's... I'm going to zoom in a little bit. It is at like maybe negative 0.5 down to negative 11, negative 12, negative 13, a little bit over 13. So I'm going to put here negative 0.5, comma, negative 13, and I think it's a little further down, 0.2. And it looks like it's actually a little bit more to the right, so maybe, there we go. That looks good. And I'm going to add a label here. I'm going to call this P3. And now to make this line, I would have to use P2 and P3 to make that line right there. So don't erase your points. You're going to end up using them more than once. At the end, you can erase your points. And if you want, you can always drag your point up so that it's right there next to those points, and keep your equations down here at the bottom. On the next video, I'm going to talk a little bit more about domain to clarify any questions. If you have questions, please reach out to me so that I can address them. And if it's more than one student that has the same question, that means I should make another video to try to explain this just a little better. Okay, so we have that. You can see how the tie would take the tie would take shape just with straight lines, which is basically this that we're doing here. Remember that we use this formula, the slope formula, y2 minus y1 equals x over x2 minus x1, and we use what we call the slope intercept equation for a line. And once we have the equation, we graph it, but we also need to restrict the domain. So this is my line. I want it to stop right here. That's negative 3. That's the point I placed right there. Less than x, and then less than, and then this point, the x coordinate is negative 1.5. Again, they come from right here. So I put the negative 1.5 right there. We don't use the y coordinates at all, the negative 6 and negative 11.3 when we're restricting the domain.